What's the difference between a good game and a bad game? That's right, today we're talking about optimization. Or for the layman, less stuff equals less rough. And for the dog lovers, it's the same, but we've spelt rough in a funny way. Now, optimization, we probably need to break down into a couple of different points. I spell optimization with an S because they don't really need to know about that. So, what is it? Let's not do that in caps. Let's not even do this one. We already said less stuff, less rough. Woof. So I guess the two main things are graphics and code. And we really need to talk about each one kind of separately. But first we'll talk about graphics, I guess, because it's the easy one. So I'm in a new project, Untitled, that I'm working on. And it's kind of like this game where you run in, you grab the key cards or whatever, and you find the escape, and you stay away from the enemies. Um, Check this out, look, YouTube channel, throw it up on the monitor. Now, as you'll notice, as I'm getting closer to it, you see the screen space ambient occlusion effect. Now, that's basically what I want to show off. First of all, I think it's ugly. I think most screen space effects are pretty ugly, except for like, glow and the other ones like that. So immediately what we're going to do to save some frames and some time, and honestly make it look better, look at this, bleh. We're going to turn off the SSAO. So in our world environment, however you've done this, it might even be in the camera. We're going to go turn SSAO off, and we're going to turn SSIL off. So anybody who tells you to turn those on, they probably do have a reason. But if we're talking optimization, there it is, optimization, then we can't be using a ton of screen space effects. So I think I had SSR on just to see what it looked like. That's just, oh geez, what's this? Alright, well I guess I'm not turning that off. That one's staying on. Don't know about that. So glow I'm going to keep on as well. Now, you see it's shaded, right? But that's because I just did a sneaky shade just then. This is not what the game actually looks like, honestly. It looks more like this. And that's not good. But just by baking the shading, the what do you call it, shadows and stuff like that, saving so much processing power. So just gonna go to light map GI. We're gonna undo that. Bam. This is the way you do it. Hit that button. Bake light maps. Make sure all of the thingies inside your level. If you're having issues with them, you can go to them. Make them a scene of their own, by the way. It makes it a lot less messy. So all of these lounges are the scenes of their own. You can't actually see it. I don't know if there's a glitch going on at the moment, but you see here, you can kind of see it. There's a really, really big version of that couch, like just kind of there. I don't know. It might be a glitch or something like that, right? But we can still work with this. So over on lounge sofa, you can go right click, make unique. And then here you can go unwrap for lightmap/AO. So if you're having issues with it as well, like just honestly right click, freaking make it local. Who cares? Just get it working. That's the thing. You go to the mesh, you make it unique, and then you can unwrap it, right? Generally speaking. I mean, this one's obvious, but in my game we don't use 3D models, so it's gonna make it a lot faster. But yeah, it's more of like a stylistic choice. These are like all bloody AI art at the moment, but we're gonna replace it. Don't worry, they're just placeholders. How cool is it that like ChatGPT can do like transparent edges now? It's crazy. Another thing is, yeah, obviously when we're indoors, I don't need a directional light, so we don't need the shadows. I mean, it's gonna make it look like crap anyway. If we could just go directional light, basically add a sun in here. Look at that. Like it just, I don't know. There's obviously no point to it when the game's indoors, but also like with shadows on, like does it really add that much? Like you really need to ask yourself, like, are shadows worth having like artifacts like this in your game? Like it does come down to style at the end of the day, but like you don't need to have every single effect in the game. You don't have to have a shadow on every single light. It's not necessary. And in fact, honestly, like a lot of the times it looks freaking ugly. So you keep it simple. Just keep it real simple. Other than that, graphics is kind of a hard one. At the same time as being quite easy because once you get past all of those simple things, it starts to come down to stuff like optimization of your models, optimizations of, let's say, animations, your textures, all that sort of stuff. But you know, these days a lot of the video cards have like a ton of VRAM on them anyway, so a lot of that stuff doesn't matter. It's just about how sort of fast your CPU can actually, you know, handle the transfer of, like, especially big files and stuff like that. So obviously going into code, we want to make sure that we aren't loading something every single frame. We try and move as much to the ready code as we possibly can. Other little things like that. Like here, we move a lot of stuff to the ready code and we move things into their own functions. And then I'll show you another little one that I like to do before we really get started. Instead of like spamming the crap out of like hide, which a lot of people might do for a UI element, you really don't want to do that, because even if the like game engine has to ignore it, if it's redrawing it every single frame, you're losing like a ton of stability, especially when you've got UI elements like constantly refreshing, because we know that they can't do it every single frame that, you know, your 3D graphics can keep up with. So for instance, if I'm about to hide this hands container, which is just like a control UI element, where is it? Hands container. I first check to see if it's visible, because if it is visible, then I hide it. Because if it's already invisible, then I don't do anything to it. So that's a really big optimization you can make, is just by handling your UI elements a little bit better. So like, there's no reason to update everything on the screen every single frame all the time. And if you do, you're going to end up with like instability, because, you know, it'll work good for a while and then it won't, and then it'll need to catch up to that. It's a bit like if I have uh, like something printing in here, like we print the delta, we run the game, and then over here we can see, look, like this is trying to keep up, but it's not keeping up. And then if I sort of stop the game or pause the game or whatever, it's like it takes a while for that to sort of happen. So unpause, boom, we're trying to catch up. Boom, pause. And yeah, I mean, obviously, if you've got a lot of things printing in there, it's actually going to take time for the engine to catch up. A little bit sketch at the moment. It's probably not a really good example, but nonetheless, now with this game, I mean, even having that delta printing in the background every frame, I can feel the instability. Like, it's crazy. Oh, you actually can't see that very well. So this down here. There we go. There we go. So let's see. Oh, oh, oh. Okay, this is just gonna make someone sick. So don't do stuff like that. If you've got a lot of printing in your code as well, just get rid of that. Like, you don't need to have that. In fact, you're going to slow down your editor while your editor is trying to run. Yeah, great optimization. So another one I really want to talk about, and this is important, right? We come back over to the blackboard. We get rid of those because we've talked about that a little bit. Actually, we'll get rid of that because we've talked about it a little bit. Now, when we're talking about code, basic workflow is we want to refactor, and then that helps us find the bugs. So if the code sucks, make it better. And then while you're in the process of making it better, you find more things that suck until nothing sucks, right? So I'm going to show you like a couple little examples of where refactoring is going to help you maybe not necessarily make your code more readable, but it'll probably make it run faster. At the very least, like with less steps, it's obviously going to run faster. Right, thanks, AI overview. Refactoring is the process of restructuring existing software code to improve its design, blah blah blah, and blah de blah. Oh, here we go. Without altering its external behavior. So when you're doing this, it doesn't make much of a difference to that functionality. In fact, it makes no difference to the functionality. It just makes it faster, better, more easily readable by like your peers or even yourself, right? So here's a good little example here. I mean, we're just kind of asking too many questions and not doing enough stuff. You know, so let's say if even we were going to refactor something like this, so the function activate doesn't do anything, but it's got an input is on, it's boolean, no default. If is on is disabled equals true, else is disabled equals false. So you kind of just need to take a step back sometimes and think about these problems in a different way. So essentially what we're getting here is this, you know? So all of this is kind of pointless because it ends up being the same thing. And let's say these were reversed, and this one was true, then all we have to do is that, and it inverts it and makes it the opposite. And we get the exact same functionality. We just delete that. And then other things that we can do is sort of inline commands, right? So let's say we had to make something visible. What's this? Alert sprite, yeah, dot visible. So you can say, well, I need to do two things, right? So there is a point of actually splitting it up into an if statement, right? So if we're getting the same thing out of that, and then we go alert sprite dot visible equals true equals false. So we got opposites kind of thing. Then all we need to do in a situation like that would be alert sprite dot visible equals true. Yeah, I need to zoom out for this one. If is on, else false. So we're doing like an inline bit of code. And I mean, at the end of the day, this might actually not run faster. It doesn't matter. There's more optimized, right? We want to just go through stuff and do this where it's appropriate. Where there's no other point, I guess, not doing it, right? Where we want to do things quickly and easily, right? I mean, even this here, it's like, all it is the opposite of that, or not, right? But we could check there are other things as well. I mean, that's one way of doing optimization. So another one would be this alert sprite. Let's say we actually get the reference to it. So you'd be like alert sprite dot visible, and then you'd be doing the same thing. I can't remember what way around it was, but let's say we do it that, like that. Whereas the opposite of it is disabled. Every time we do this, we have to actually retrieve the position in the scene tree, right? So instead of doing this, although if we do it here, it doesn't really make that much of a difference because we're activating, you know, maybe like once every second even is enough. That's fine. But if we're doing it every single frame, using this sort of referential system is really, really, really bad. So people might see bits and pieces of code and try and type it out. I think you're going to type it out. I pretty much did at the start. I didn't actually realize that if you hold down control, if you click, you hold down control while you're dragging it over, it's going to pull that in as a reference to what you were referencing before. And this is going to be a lot better than doing it the way that showed you before, where we just grab the direct reference and then edit it directly. So like I said, for functions and stuff like that, it's not that bad. But if you're using it more than once across your code anyway, just pull a reference in and do it the normal way. Alert sprite. Honestly, doing it this way I think is stupid because we are devoting part of the CPU to figuring out where that node is, where you know we don't have to. It's right there. It doesn't change position or anything stupid like that. That's another thing you kind of need to take into account is if you are running things every physics process versus every process frame, you're going to get different results. So if you're putting anything camera related into physics process, it's going to look like the game is lagging, and it might not actually be lagging. Maybe looking at your FPS, like, oh, it's 144 FPS. Why am I only moving at 60? What the hell is going on? And that's because you put something in the physics process. So with the physics where is it? Ticks per second. It's like 60 ticks per second by default. Yeah, there it is. Physics ticks per second. So you don't want to turn this up too high unless you have to. If you're having trouble with the physics, don't turn this up immediately. What you should do is turn on continuous, what do you call it? Let's get my rock out. Yeah, rock scene. Continuous CD. That's the first thing that you should try. If that doesn't work, switch it over to, well, you should probably try Jolt first, honestly. But if that's still not working, yeah, continuous CD. And that's just going to make sure that the physics thing stays. I don't know. I think it like extrapolates instead of interpolates, right? Something like that. I don't know. I don't really know. It doesn't work perfectly. It kind of sucks, honestly, but you know, go Jolt, whatever. Physics process will only happen 60 times a second. So if you've got your camera or anything else like that in there, it's going to mess around. So what I usually do is I calculate my velocity and my stuff like that inside physics process, and I actually apply that on process. Or with the new Godot 4.4, I can actually put the move and slide inside physics process and then just interpolate the player, because you're not really going to realize that anyway. But you do notice if you've got the camera in process, the camera stuff in process, but the movement stuff in physics. No, that's the way that it should be. If you've got your camera in physics, you're going to notice it. It feels like crap. It's just bad. So another one, before importing anything into your project, you should check the size of it. It seems pretty obvious, but there's always ways to make things smaller. I mean, this PNG is 0.5 megabyte, and I would not put that into my project. I would make it way, way smaller before I did that. And same goes with, let's say sound files, MP3s and stuff like that. You really want to convert it over to .ogg. So smaller files, .ogg, audio, and you probably still want to use PNG, but honestly, there's nothing wrong with JPEG. Whatever gets it to a smaller file size and doesn't have that much artifacting. Honestly, like in games like this, I usually turn off the sampling anyway. And you usually only notice what's called artifacts, like JPEG artifacts, with your sampling set to linear. So with this sprite here, if I then go down to the sampling mode and then I turn that on linear, like, I don't know, something about it looks jank, but as soon as I switch it off, give it that little bit of anti-aliasing fucking sharpness, yeah, it doesn't matter how small the file is. Although I think this one is kind of big because of transparency. Oh yeah, so PNG for transparency, that makes sense, and JPEG for no transparency. Wouldn't be really using GIF these days. GIF sucks. Boo, boo GIF. Boo GIF. GIF sucks. Oh, yeah, goddamn. Chill out. Goddamn. Alright, so in this one, for instance, when we try to find the player, relax. This is the enemy nurse, right? In her code, we go to find the player. The player is declared at the start. Obviously, via type player. And then in ready is where we grab it. Right, so this would probably function exactly the same. Where is it? If we were to put this in, wow, I don't actually have a process. That's actually really good. So this code only runs 60 times a second. So if I was to put this in here, it would sort of run exactly the same, except we're checking, we're trying to find the player every single frame. We're trying to grab it from the group every single frame, which is just friggin' stupid because the player doesn't change. So we're going to start using things like signals to figure out when a new player spawns in and stuff like that. And then when it does, we tell the enemy, okay, well, this is the new player. Or every time you get a reference to it, get a reference to the player inside like an auto load or a global or something like that. Like I've got this thing called Game Manager here. And Game Manager has all of my what do you call it? All of my like, yeah, global stuff. So I use signals a lot because from any bit of code you can, fire off, you can emit any signal globally, and it can cascade out into your entire project. So it's kind of the way that I set things up. Where were we with the nurse, right? So yeah, don't do this. Don't do that. Don't be trying to find stuff every single frame. It's just stupid. Try and do things inside the physics process if possible, if it makes sense. Obviously, with player, it's going to be a little bit different, but we also don't want to have too much intense processing inside physics because it's really intended just for the physics stuff, and then everything else sort of done on the frame. But if you are doing all of this velocity finding stuff on physics, uh, it's going to actually function like it should physically. But if you're doing it on process, then it's all going to depend on how fast your computer can process frames. Like old school DOS programs running at like 500x because we've got quad cores and 5 gigahertz processors and stuff like that. Uh, yeah, that's an easy one. Another one here is we're going to use a lot of Area 3D body entered. Uh, every now and then we kind of have to use a bit of code to rectify any issues that may come as a sort of result of this. But let's say for my nurse enemy here, she's got like this bubble in front of her right there, where if the player walks into that bubble, that's the only time that the get captured code actually fires off. So she can't actually catch you until you fire off the signal for that area 3D that you've actually walked in there. Now I can put that bit of code on process if I wanted and check every single frame to see if the player was in there, but that's stupid, right? So to optimize, we're going to pull that down to an area 3D body entered signal as opposed to, like I said, process or physics process. So, in here we could be like area 3D. What is it? Area 3D. Yeah, so we don't even have a reference to it. That's good. That's freaking sweet. So when I say rectify problems that come as a result of that is there is a niche issue where if there is a wall in front of this chick right here, like this, and you somehow walk into the wall, she's like this, right? She's looking that way. If the wall's here, and then the raycast hits the wall, right? But then you're actually inside of the circle, then it's going to fire off the code that you entered in there. It's not going to see you, and then it's not going to fire it off. So that bit of code there is, I mean, it checks with the raycast after it checks in the body entered signal. And that's just to make sure that she's not getting you through walls and stuff like that. Because I don't know if you noticed, but the walls in this game are like razor sharp thin. Like they just don't exist in that dimension. So they could get you through walls and stuff like that. So I needed to check if they were actually looking at a wall or not. Yeah, that being said, if you're standing next to a wall and so is she, she'll walk into you and she'll continue to walk into you and follow you around like Pikachu in Pokemon Yellow. All the while not actually doing anything because you're not firing off that area 3D signal to check what's inside. So, I mean, with the rectification of that, we could do something like this. And there is a point to this. I'm not going to put it in process because we don't have to check every frame. We have to check every physics frame because that's when things move. There's no point putting in any other one, right? So we got the move and slide. Just going to do this before that. Then we can check in here for the bits of code. So it has overlapping bodies. This is the one that we want. So area 3D dot has overlapping bodies. So the reason we do that is we're not going to check to see if the player is inside that circle every single physics frame if there's nothing inside that circle for most of those physics frames, right? God, you make me stupid when you don't follow direction, dude. And now what we have to do is get overlapping bodies. And then we go if player in get overlapping bodies, the area 3D dot get overlapping bodies. Then capture. Is that how we're doing it? I don't actually know. Here we go. If collider is player, yeah, here we go. So capture player. We'll just make a new function because we're not going to type that bit of code out twice. And that's the whole point of refactoring, is not having a bunch of crap code all over the place that doesn't do anything. Or that does the same thing over and over and over again. Because then if you know, if I want to make a change here, I need to make sure that it changes on the other side of the code as well. Body.get captured. Alright, here we go. Get captured. Player body. Is a player. So capture player, collider, bam, and then we go player body, get captured, capture player. Alright, cool. So then we want to do capture player. Oh god, so frick. Oh wait, we just put the player in there. Yeah, okay, easy. So that's another optimization as well. Like this part of code I could have typed out completely differently. In fact, I'm going to type out the dumbass way to do it right now. I'll show you. So we're going to use that again, actually, because we're not going to do it that stupid. And now we go var overlapping bodies. Yeah. Equals get overlapping bodies. Look at this. For I overlapping body and overlapping bodies, yeah. If overlapping body is player, well, you don't even need to do is player. We'll go equals player, because right here we're going to go var player equals get tree dot first node in group player. So we're actually not going to do that. Like that's really cringe. So this would be 60 times a second. We would be getting the player, getting all of the overlapping bodies, and then running an iterable for every single one. So if overlapping body equals player, then we could be like player dot what did we create before? Capture player player. So that's a piece of crap code. That's why I'm laughing at it, because that's just crap. Don't write things out like that. You need to just break it down into its constituent parts. Understand like the different functions or functionalities that you have inside of Godot if play in Area 3D, right? So yeah, we get rid of this. We use the good code, right? And I know that's going to work, so I'm not even going to test it. Not even going to test it. What I will do, however, is we can open the game up. We'll have a little bit of a... There we go. We'll have a little bit of a rant about why I use Godot. Man, have you ever tried to use Unreal? Dude, Unreal sucks. Like, I used it for a little bit, and I was like, man, it's pretty cool. It's like, you know, I was sold on it for like maybe a week. And then I was like, you know, how do I make like just a small little project? And it's like, it's just not possible. It's like every single project that you make in Unreal is a big project. And the same goes for Unity these days. Like, I know I'm probably an idiot in saying that, you know, to a massive game development community, but that's just the way it felt for me. When I write music, you've got choices. You can either use like a lot of the inbuilt tools, or you can pay for or download legally a lot of like VSTs it's called. VSTs are like plugins. And I mean, obviously the most pure way of making a game is without any plugins and you've made all the code yourself, but yeah, that's unrealistic, right? But is it? Because you don't need to have all of these crazy features and stuff. You just need to sort of boil down your game to what it needs to be and have that as the bare minimum. You know what I'm saying? Let's hope this one loads up, because this is a good example too. Oh yeah, here we go. So this game has had the crap optimized out of it as well. Just optimized absolute crap out of it. And like I don't think it looks that bad. So that sky there is called Sky 3D. Sky 3D? Wait, what button is this? K. Alright, so what this game needed is it needed a day-night cycle, right? That's why I put the day-night cycle in there. I actually had my own sort of version, but I found like a plugin that was really, really good. It's called Sky 3D. It's by the same people that made, God, I can turn this down, don't I? The same guys that made Terrain 3D, which is exactly how I'm getting this terrain right now. God damn, this game is so cool. Oh, it's hard as F too. I really gotta release this, probably on itch. Thinking of releasing, yeah, this one on itch, because this one is really fun. Yeah, bam, 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 bam. Bam, 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 bam. So sick. As yeah, you think about the bare minimum, and you get the bare minimum done, and that's why I love Godot, because it starts out as the bare minimum. Problem with Unreal is, you know, it gives you all these options. That same with Unity, honestly. It gives you all these options, and you're like, oh hell yeah, I want like, you know, seriously cool graphics, and I want like all this other, you know, like insane, like nutty stuff. But like you never end up using it, and so all it ends up being is bloat. And you don't realize that, but it is. And then, and then you try and show people your projects, and then they're like, okay, cool, bro, it runs at like 15 FPS. What's up with that? Like you go and download a bunch of models off the internet, that have like 5 million polygons in it, and you expect the game to run good? It's freaking dumb behavior. I mean, this game looks alright, yeah. Looks alright. It's not meant to be that fancy. I don't want it to be fancy. Because it's all about the... Oh, it's all about the swag, dude. Check that out. Oh, what's that? Is that unaccessible? What a sweet transition to our sponsor, which is me. Buy my games on Steam if you want to directly support me. Unaccessible is my latest and greatest. And then we've got DJ Simulator, my that thing from Mad Max, Opus Magnum. And then we've also got Let Me Book, a scary game that will actually, if you can play the game and not get scared, I'll Venmo you $4.50. No, 20. But you get scared, you're a puss. Alright, I probably ranted for a while, but yeah, anyway, that's why I use Godot. We've got completely stripped down features. Nothing crazy. No night, doing like some automatic LOD. Like, bro, I don't need LOD when we've only got like 100 polygons per thing. And like, it doesn't necessarily need to look low poly or anything like that. It's just start simple. Just start simple. Alright, make sure you subscribe, all of that stuff. Good to see you fellas. And I'll catch you boys next time.